because the cost that we have to spend to bring in a bullet train versus the kind of efforts that's required to the number of people that will move, already there is a competitor in place for a bullet train, which is going to be cheaper than this. I'll keep showing you next slide. Next slide, please. This is a magnetically elevated train. You can see the single track. There are no double tracks here. The whole train floats magnetically, and it keeps moving at rapid high speeds. Next one. Then we have the same bullet train in a capsule form. Next one. Hyperloop, how many of you have heard? Good. Yeah. You know how simple this technology is in a hyperloop? It is just one tube. You remove out the air, put in here. Because of atmospheric pressure, this fellow moves from here to here. What is simple? This one or the bullet train? I'm not getting any answer from the audience. Hyperloop is simpler. So that's why I was telling you, by the time bullet train comes, Hyperloop will already be in place. Then we'll feel that we have wasted so much of money on the bullet train, we should have gone in for the Hyperloop. It is exactly like buying your phone. You save a lot of money and you buy the phone, and then by the time you buy it, there's another new phone model which is already out. Oh, I should have bought that, I simply bought this. And then you start saving all over again. Okay, it's a different trip. This, since you know it, we'll skip this slide. Next one. Top one particular thing is 760 miles per hour speeds. This is what you must remember. This speed is slightly higher than an aircraft on the ground, which would mean it's completely a revolutionary kind of travel. No takeoff, no security, and no complicated boarding the aircraft and then getting off the aircraft, your luggage coming elsewhere. This is a direct, straight thing. You enter into the station and point A and point B, you're already there. The questions asked are how our body is going to handle that kind of speeds, because you have something called the G-force which will be acting on you, the soft acceleration that will come into question, the rapid stops. Though you may not feel anything immediately, there are effects on the human body traveling at such kind of speeds close to gravity on the ground. And the sky, it's a different mathematics altogether with your body. This is how it looks. You must have seen this picture. Next one. This is in Abu Dhabi and certain places in the Middle East where they're building systems already. They would like to experiment with it. They are very clever fellows. The Middle East hasn't gone for trains as yet in a big way as we have gone. They still believe in the road transport. This is the first time they said, let's knock out the cars and automobiles. Let's get this Hyperloop straight away. The first guys who said, let's invest it together, and 6 to 7 big investors have come into question now. Together, they are investing in it because they know this is the transportation for tomorrow. High size, big size, small size, all things will finally maybe end up in the Hyperloop system itself. Just press enter. You can see the way, the speeds with which you are going, how it stops. Sound is very low. Yeah, okay, fine. Yeah, you can move on to the next slide. See, this is the typical situation of how the Hyperloop will come into operation. people in the rear, you're able to read the thing? Yeah. What will drive the Hyperloop train at that speeds is, such kind of magnetic levitation. Do you know that this concept of a Hyperloop is 100 years old? People don't believe it. Way back in the 1920s, some scientists abroad had thought of it that why can't we have tubes with vacuum and then put people in and then it just devacuumize it, it goes from point A to B. But those people did not have the kind of electronics we have today. They did not know how to create that kind of vacuum and they didn't know how to create this kind of magnetic levitation. But this was being talked about. If you see the internet, you will find it. From 1940s, magnetic levitation is being talked of. Then the linear motors came into question. After linear motors, we had different kind of motors that came into question. Even today, the laboratory scales have not taken off into a commercial scale because we feel that there is no need for it. But now everybody is waking up. The last point of my discussion, I will come back to what is the importance of all this transportation system, what will happen to us actually when we start using them. And some more interesting solutions are there. This you must have been seeing in the WhatsApp, where there's a bus which moves on the road and vehicles passing down below that and then it comes in. It is a moving flyover rather, which carries people. China is already doing it, but they have found out that this experiment has been a very foolish, expensive one. So they're withdrawing it out because the kind of roads it requires, the infrastructure it requires, and the way it starts blocking vehicles moving in this direction. They can move along with it parallelly, but not perpendicularly. You need to wait for this vehicle to pass before they can pass the road. So these challenges are like really making people think, are we in the right direction for this particular kind of technologies? This one more slide. We come to India, dear India. All this we talked 2050. What are our challenges? 16 people are dying every hour due to road accidents. Do you think we will ever have driverless cars in India? Huh? We could. This is where all of you are going to fit in, to write the algorithm for India. What kind of algorithms we need to write? What will you make this cow to eat? Will you mix a RFID chip in his grass and ask him to swallow it so that we can detect him? What do we do with it? And he says, I have an equal right on the road as much as you do because this was my area. My great-grandfather had a forest here. You jokers, you have made a road and you claim it is yours. And these fellows have such a beautiful mind of their own. One IIT Delhi, there is one professor called Professor Dinesh Mohan. He works on road traffic accidents. So I had an opportunity to work with him for a long period, almost 11 years. We developed a lot of safety standards for the Indian Automobile Society. That's when I told Professor Dinesh, let's do one study as to why cows are very fond of sleeping on a road in the evening. Then we made the study. We put some 2 IIT volunteers. The students just refused. Sir, our parents have spent so much of money, have passed entrance exam, not to go and count cows on the road. I said, hey, guys, just go there. This is an interesting experiment. And then first experiment, what they did was, they drew a curve, which season you find maximum cows on the road. The curve was between September to February, you find maximum cows in North India, which are sitting on the road. And then the second curve was taken, which is the time when they love to sleep. The time when they love to sleep is between 4 to 9 p.m. evening. The reason was the roads having so much of traffic for the whole day gets nicely heated up. These fellows feel that they're very warm and cozy on the road, and now it is our time to enjoy on the road. And it was a hell of a task for lorries and cars and everything which were on the highways moving around. They really had a horrendous time. But now, of course, we have the cow guards and these fellows can't come in. A lot of places things are there. But this is not uncommon. Recently, I was in Uganda. In Uganda, I was talking to the African students. And mind you, Africa is not as we think. We look very primitive in front of their behavior. They are highly sophisticated people. When I showed the cows and asked them, what do you do with the situation? Sir, we will eat it up, simple. If we are going to have a meal ready on the road every day, we are going to eat it up. And the problem is solved and we are very happy. I really liked it. But India, no, you can't touch him. He is holy. Okay. You see this? Now, we are all laughing away, but just imagine the kind of friendliness. This fellow is laughing, the donkey is extremely happy. He is getting a nice ride. He said, for once I am riding on the road and now I am being carried around like a VIP. And which intelligent car is going to understand the situation, whether it's a donkey or a human? It will think that I'm finding somebody with 4 legs, man, what do I do? And the next car says, even I haven't seen a guy like that. So you tackle that problem yourself. And then they're all sitting comfortably on a moped. And look at this. He still happily just taped it like some envelope and is going around the whole town with an accident. Now see this chaos. If you make an algorithm to avoid collisions in such a situation, to find a way out of this traffic jam, the computer will crash. Every minute there are going to be so many variables which are going to come in. Every second rather. So there isn't any order here, absolutely, totally. And this, especially this gentleman, the car wouldn't know whether he is going with the traffic or opposite the traffic or what is planning. It is in the middle of the road somewhere. And this fellow is right here, wear helmet, so he is very happily going around, and this is the kind of overload, and this fellow now is on both sides of the traffic, this side and this side. This, my friends, is the challenge, and this is where I'm going to take questions from you all now. Okay? There are a group of people on my left side last who were very busy discussing something. I would like to know what was it about. Do you want to give a solution for the Indian scenario? My friends at the end. Okay. Would you have any questions?
Any questions? Is there any risk in automatic driving cars? Like, is it possible to get hack into the systems of automatic drivers and get control it from somewhere else, from other part of the world?
That is one of the biggest fears. Because today, if you direct, say, 200 cars to enter into a campus, there will be chaos. And they wouldn't know why they are doing it. You got it? You have to make a counter hack-proof software where to enter it has to be only 2 cars can enter into each other's control system, not a human being. Ultimately, a master control should be there which is completely uniform, which is going to control all the automobiles to either stop at one place or move to the left or right side of the road. Yes, that challenge is going to exist. You can hack into it. It's not going to be a very sophisticated technology.
So it's not safe?
A question of safety is totally on ethics now. What you want to do with the hacking. If it is just for the fun, making the car go in the reverse all the way from here to somewhere and provide amusement for the people, then that's about it. Why do you want to hack it in the first place? Why would somebody hack it?
No, it's like the system has to be so much secured so that nobody can hack into that.
No, the question is, when we spend money for security, we need to understand the net loss. What happens if you hack and penetrate into it? If it is going to be an act of disruption, where you want to disrupt a country's transport, for example, they are going to all have a uniform code of movement or a uniform code of control. The whole country will have something called a national control platform. Like India could be India-specific platform, which can detect cows also, which I was showing the slide. And if that is going to be there, the whole country will come to a halt if somebody hacks it. This is going to be more of a very high-level security threat in case, if at all it comes. But whether it can be hacked or not hacked is really not my question. Engineers must think about it, how you protect it. Okay?
Thank you, sir.
Welcome.
Any questions?
You were speaking about the driverless cars. The driverless cars as such are good for the plain roads, but when it comes to hilly or muddy roads, how do you tackle those?
See, this is going to be for India. If you take, we are still yet to evolve. We have roads of 1920s and vehicles of 2015s. There's a huge gap. So for this particular situation, if you're going to have hilly and pothole-filled roads, we can't be operating a driverless car there. So we'll have a board, driverless cars, no entry here. It's only humans who will be enjoying this road. Okay, that is the only solution, because then you will have to build such a kind of humongous algorithm into the car to detect a pothole, a boulder, and this and that. It's not worth the exercise, finally. So it's not going to exist there. Yeah.
And one more thing about the electric cars, electric vehicles you mentioned.
Yes.
Even the Karnataka road transport is thinking of getting the buses replaced by the electric buses.
Yes.
But each electric buses costs minimum around 1 crore. So is it worth spending so much?
Okay, now this whole slideshow, what I showed you about the future of transportation, the reason is the world, what it was about a century ago, completely green, clean, nice water, nice atmosphere, will return back to that situation with these things now. The biggest culprit has been the automobiles of the current genre, more and more of them. Even if it is going to cost us 1 crore for the electric bus, I would advocate it. They should take it because the kind of pollution footprint it has is extremely low. There will be a total comfort zone for all of us tomorrow with vehicles of that kind. So cost is not a factor here at all. The factor is convenience and how much of impact it has on the environment.
Thank you, sir.
Welcome.
Any questions?
Okay, I would like to just discuss with you one very important thing. What is going to go into tomorrow's transportation techniques, which is connected to what you are studying now? Number one, you need to concentrate on motors. Specifically, brushless DC motors, which are inverter driven. These are the motors for all the vehicles that you saw here in this picture, the drone to the train to the cycle to the automobile. Second thing is how you charge batteries, the power supplies. People who are doing power electronics here, you must concentrate on your power supply front because most of these vehicles will have contactless charging, what we call as wireless charging, which is an inductive process. Now in this inductive process, how the power supplies can be designed to give large bursts of electromagnetic waves, which the other fellow can pick up and then convert it into electricity for charging. This is an interesting topic for you. Third thing is about batteries. All of these require storage batteries. Which kind of batteries are going to fit in? I would imagine that anything around the lithium polymer side is going to possibly be there as the battery for the future, for tomorrow. So please study on the lithium polymer batteries. And then finally we are talking of signal processing between different vehicles, the speed of signal processing, how this vehicle transmits signal and that receives it. These two things, the distance between the two for communication, whether it's going to be 1 meter, 2 meter, 10 meters, these are all going to be at extreme high frequency signal discussions or whatever this thing. Then control systems. What kind of control systems are going to come tomorrow for the steering control? Is it going to be servo driven or hydraulic or a mix of both? These are some topics for you. Because the manpower the world will require for this is going to be so huge. I just cannot imagine the number of jobs that will possibly get created in this particular space. But every country would start investing money for this technology because they know that in this there is a future. The future has nothing to do with moving people. The future has got something to do with the method of moving people. This is a very clean, green way to move people. Our carbon dioxide footprint, what we have today, the kind of global warming, what we are talking, the kind of water disappearing, potable water, and all the environmental disasters, things will start getting reversed slowly with this technology. Transportation is a 60% contributor to the global nonsense that is happening in the atmospheric disturbance. So as engineers, you people have an enormous responsibility to start working on these things. Those of you who are keen to do some kind of a project or get associated with more information, better get geared up. You can feel free to contact me. And I am sure if you all work in the right direction, each one of you could land up 3 to 4 jobs. Okay? So with this, I take leave of you. Thank you for your attention, though it was not a very interesting one. Things that we talk of tomorrow are not interesting. Things that we talk of yesterday, like the cows, seems to be more interesting for you people. Anyway, get up. Okay? All the best wishes. Thank you. Have a wonderful time. Yeah, there is an interesting thing what Professor Praveen Kumar just brought in. How do you convert an idea into a product? How do you take it ahead? First of all, start thinking of the product or the idea as it is, and then think of the combinations of success and failure as an engineer. You can't use a motor of this size to make a man fly. Though the concept is interesting, you wear a hat, you have a motor, you have a battery in the pocket, switch it on, you just keep going. Concept is excellent. But then you should think as an engineer, is it physically possible? Can the motor lift off a weight of 80 kilos or a 60 kilo person off the ground? What power is required for that? How do you require? How long will the battery last? You will take off and then land with 1/3, or you can go for a distance. So this way, you have to start thinking logically if a concept can work, then make a scaled down prototype. Yesterday, I had one gentleman with me. Akshay is here. He's in some other class. Okay, there's one gentleman called Akshay Kumar, one of your fellow students. He is taking us around the whole of city of Mangalore. He wanted to make a car on fuel cells. I said, that's wonderful, but if you want to use fuel cells, the concept what you thought is brilliant. But there's something called proof of concept. You make a very small size fuel cell first. Let it charge your telephone, or maybe just light up even a LED. You will know all the pros and cons of the entire process as to what is its capacity, what is its size, what is the cost, and how we can make a complete finished product. Then you can start scaling up. Please do not do things for impressing others, because the other man, maybe me itself, I may be stupid. I may get enamored by the idea, looking at the design and the color of it. Oh, this is wonderful, you have done a great design. We haven't gone anywhere with that. Please do something, a product or a concept, where you have understood the fundamentals thoroughly. You have a hands-on experience, and you have the whole life to bring out the product, but you don't have the whole life to learn about the product. This is your time when you need to learn. One product I will tell you, there was one charka which could generate electricity, the Gandhian charka, which was re-innovated. It went around the globe. That was a product of mine. It took me 27 years to bring the product out, but I didn't stop. Reason was, fundamentally what I did initially, using a cycle dynamo as a kid, I generated electricity, did not know how to store it, how to light up a lamp, but the concept remained. When all the components came into place, finally the product would come out. This is the way you should take your concept to an end product. You will surely have success. But this process is the same whether you want to make a rocket or a small pin. It is the same process everywhere. All of it requires the systematic thinking. Thank you.